In this video, we're going to talk about types of chemical reactions: synthesis reactions, decomposition reactions, combustion reactions, and then single and double replacement reactions. So what is a synthesis reaction? This is a reaction where you have multiple reactants combining to form a single product. So A plus B turns into AB. Let me give you some examples. So if we take zinc metal and react it with oxygen gas, this is going to turn into a single product, zinc oxide. Now this reaction is not balanced, and we really don't need to do it for the sake of this video. But notice that we have two smaller components and we're generating a single product. That is a synthesis reaction, which is also called a combination reaction. Zinc and oxygen are pure elements. Zinc oxide, that's a compound. It's made up of two different elements. Here's another example. If we were to take barium oxide, which is a compound, and react it with carbon dioxide, which is another compound, this will give us a single product at low temperatures known as barium carbonate. This is also a synthesis or combination reaction because we're taking two smaller components and combining it into a larger product or a single product. So that's the basic idea behind a synthesis reaction. Now, before we go into the next type of reaction, I do want to mention, for those of you who are watching my videos and who haven't subscribed yet, feel free to take a minute, hit that subscribe button, and don't forget to click on that notification bell. That will be greatly appreciated. Now let's get back to this video. Decomposition reactions. A decomposition reaction is the reverse of a synthesis or combination reaction. So in this case, you're starting with a single reactant, AB, and you're going to break it up into two or more products, typically A plus B. So a good example of this is magnesium nitride. So this is an ionic compound, and when heated, will decompose into its component elements, magnesium and nitrogen gas. So here we have a single product breaking down into multiple fragments. So that is a decomposition reaction. Another example is the use of calcium carbonate. If you heat up calcium carbonate, you can represent the heat phrase with, the word heat with a triangle. If you heat up calcium carbonate, it's going to decompose into calcium oxide and gaseous carbon dioxide. So that's another example of a decomposition reaction. It's simply the reverse of a synthesis reaction. The third type of reaction that we need to talk about is a combustion reaction. Combustion reactions typically involve some compound containing carbon, hydrogen, and or oxygen. And typically, the most common example of these reactions is that you take that compound, react it with oxygen gas, and you're going to get two products, carbon dioxide and water. So here's an example of one. Propane C3H8 reacts with oxygen gas to produce gaseous carbon dioxide and liquid water, depending on the temperature. If the temperature is above 100, that's going to be steam, so we'll put H2O with a gaseous phase. Another example would be ethanol, C2H5OH. So this is an example of a compound containing carbon, hydrogen, and oxygen. When ethanol reacts with oxygen gas, it too can create carbon dioxide and water, assuming there is sufficient oxygen gas to react with it in the first place. Otherwise, carbon monoxide could be created as well, which is not a good gas to deal with. But with sufficient oxygen gas, this reaction will go to completion and you'll get carbon dioxide and water. So those are examples of combustion reactions. Combustion reactions are very exothermic, which means they release a lot of thermal energy. When you react gasoline with oxygen, let's say in a combustion engine, it will generate a lot of energy, a lot of heat energy. And some of that energy is used to power the car to make it move forward. And so combustion reactions are very useful in terms of everyday applications. Now let's move on to the next type of reaction that we need to consider, and that is single replacement reactions. In a single replacement reaction, you have the general formula A plus BC turns into AC plus B. So what happens is, in this example, A displaces B out of the compound, and so B leaves. It's now by itself. So let me give you an example. In this case, for this type of chemical reaction, you're going to have a metal displacing another metal out of a compound. So zinc metal reacts with copper chloride, that is aqueous copper chloride, which means it's dissolved in water, to produce aqueous zinc chloride plus copper metal. So notice that zinc displaced copper out of the solution. So now zinc is in the solution, copper is now a metal, a solid metal, that is not dissolved in the solution anymore. And so that is a single replacement reaction. Zinc replaced copper out of the solution, or kicked it out of the solution if you want to say that. Now there's another type of single replacement reaction. In this example, we considered a metal replacing another metal. You can also have the situation where a nonmetal replaces another nonmetal. The general reaction for this type of situation is going to be A plus BC, and that's going to turn into BA plus C. So in this example, A, let me use a different color, A is going to displace C out of the solution. So here's an example. Let's say we have liquid bromine in its elemental form, and we're going to react that with a solution of sodium iodide. In this reaction, notice that bromine and iodine, or in this case, it's in the form of known as iodide. Both of these are nonmetals. Bromine and iodine they're not metallic. So bromine is not going to displace sodium because sodium is a metal. Bromine is going to displace another nonmetal like itself, in this case iodine. So what we're going to get is sodium bromide, which is in an aqueous form, plus elemental iodine, which is a solid. So in this case, we have a nonmetal displacing another nonmetal out of the solution. That's the second type of situation that you'll see when dealing with a single replacement reaction. Now, the next type of reaction we need to consider is a double replacement reaction. In this reaction, we have AB reacting with CD. Now, what are the products that you think we're going to get? Now, notice the keyword double replacement. The two middle ones will come together, that's B and C, but it's going to be written as CB, not BC. And the two parts that are on the outside, they're going to pair up together, and it's going to produce AD. So those are the products of a double replacement reaction. Let me give you an example. Aqueous calcium chloride reacts with aqueous sodium nitrate to produce aqueous calcium nitrate plus aqueous sodium chloride. So this is an example of a double replacement reaction. We can see that calcium paired up with nitrate. In this case, this would be AD. I have them switched around for some reason. And sodium paired up with chlorine, as we can see NaCl. So notice that Na is written first. This is actually Cb. Cl is written later. If you break this up into ions, you'll have calcium 2+, you'll have the chloride ion, Na+, and the nitrate ion. Notice that the positive ions are written first. So that's why sodium is written before chloride, because it has the positive charge. Calcium doesn't want to pair up with sodium because like charges repel. That's why calcium pairs up with nitrate, because they're opposite charges. Calcium has a 2+ charge, nitrate has a -1 charge. Ions with opposite charges will attract each other, and that's why sodium is attracted to chloride, because they have opposite charges. So you shouldn't see calcium paired up with sodium. They have the same charge, that's not going to happen. And you shouldn't see chloride paired up with nitrate. That's not going to be correct. Now there are some other types of displacement reactions, or rather double replacement reactions, that you need to be familiar. And some of these have special names. Consider this one. Let's say if we react calcium nitrate with sodium phosphate. Both of these compounds are in the aqueous phase, which means they dissolve in water. They're water soluble. Now this is going to produce sodium nitrate, which also dissolves in water, plus calcium phosphate. Now calcium phosphate is not water soluble. It is insoluble in water, which means it doesn't dissolve in water. Now this reaction will be visible. The other reaction is not visible because everything was in the aqueous phase. But for this one, notice that we get a solid product. Whenever you mix two aqueous solutions, and if it produces a solid product, then the double replacement reaction has another name. And that name is a precipitation reaction. Calcium phosphate precipitated out of the solution. So this is an example of a precipitation reaction. You may learn this later if you haven't learned it already, but at least now you know what it is. Here's another one. If we take sodium sulfide in its aqueous phase and react it with hydrochloric acid, this is going to create sodium chloride, which will also be in the aqueous phase, but we'll also get something else, H2S, hydrosulfuric acid. And this is a gas. So notice that not everything is in the aqueous phase. We're mixing two aqueous solutions, and we're getting not a solid product, but a gaseous product. So this type of reaction, even though it is a double replacement reaction, sodium paired up with chlorine, hydrogen paired up with sulfur, even though it's a double replacement reaction, it also has another name, and that name is known as a gas evolution reaction, because a gas evolved out of the solution. So that is a gas evolution reaction, another type of double replacement reaction. And for those of you who are curious, there is another type of double replacement reaction. And here it is. Let's say we react hydrochloric acid with sodium hydroxide. In this example, sodium will pair up with chlorine, forming table salt, sodium chloride. And then hydrogen is going to pair up with hydroxide, forming water. Now, water is not a solid, it's not a gas, but it's a liquid. So what do you call this? This is still a double replacement reaction, but it also has another name. And the name for this reaction is an acid-base neutralization reaction. Why is it called that? Well, HCl is an acid, hydrochloric acid. Sodium hydroxide is a very strong base. Whenever you mix an acid and a base, specifically a strong acid and a strong base, they will neutralize each other, creating salt and water. And that's all, folks. That is the end of this lesson. So for those of you who found it to be helpful and very informative, make sure to hit that subscribe button, double tap it if you have to, and click on that notification bell. So thanks again for watching, and I'll see you hopefully in the next video.